You're welcome to my YouTube channel, Mersthub Mentors. This is Python for All. In today's video, we will be discussing error handling in Python. Error handling in Python refers to the process of dealing with errors during the execution of a program. Errors can occur for a variety of reasons, such as syntax error, type errors, and runtime errors. To handle errors in Python, we will use the try and except statements. Mind you, Python has an exception built-in class, which we are going to discuss in depth when we get to object-oriented programming on how to write custom exception classes. The try block contains the code that you want to execute. If an error occurs in the try block, the Python interpreter will raise an exception. The except block is used to catch the exception that is raised and handle it in a controlled manner. Let's look at a simple example of error handling in Python. Here we have try. We want to divide 10 by 0, and we know that what? It is not divisible by 0. So it raises an exception, which is a 0 division error, and then we catch that in the except block and then print this number is not divisible by 0. So if we run this cell, it returns this number is not divisible by 0. Also, you can bundle your try and except statements inside your function block. You can use it in your class block, okay, to catch errors and or handle errors. Okay, so here we have a function check zero error, and then we pass in an input, an argument n, which could be of any type. So try print n divided by 0. Okay, but you see here also I'm trying to capture more than one error. Okay, so I'm printing n divided by 0, which I know will give me a 0 division error. I'm also printing Python for all, which is concatenated with n. Okay, which will likely give me a type error. So I can then put in these two errors, 0 division error and type error, as a tuple in the except block and print an error has occurred. Running this, put that function in my namespace. So if I check, run, check, 0 error of 10, what do I have? It prints out an error has occurred. Okay, so next, I will modify this function to a second version. Here, I want to include the else statement in the try except statement block. So I have try, print n divided by 0, which returns a 0 division error. Here I output that the number is not divisible by 0. Else. So what happens in the else statement is that if the try block does not raise an exception, of course, the except block, okay, doesn't throw up the print, okay, the output of that exception because no exception was captured. The else block gets executed and it prints no exception occur. So let's run this and then check error of version 2. If you click on this, you see it says 2 is not divisible by what? By 0. What about if you have 0? Let's see what happens. Check 0. If you run it, it says 0 is not divisible by what? By 0. You can see that the else block does not get to run because an exception is raised. Okay. If, for instance, I change this to 2, right? And then and I run this again, what do I have? And I check of this, it returns 0, and then it prints out. You see the else block, then here is executed because there was no exception that was raised. Okay, so let's return this back to what it is. Now, in Python, we can also raise exceptions in Python using the keyword raise. You can raise both built-in exceptions or and custom exceptions. For example, The code below raises a zero division error exception by calling raise zero division error, and also a value error exception with a custom error message can be raised also using raise value error. Now, what I'm saying in essence is that in Python, there are two ways you can handle error. You can either use the try and except block, okay, to handle it, or you can raise the error that you yourself that you know that may likely happen. You raise it yourself. So let's take that example. Here, I will import NumPy and then define map mul A and B. I'm trying to do matrix multiplication of A and B. So I will try, okay, multiply A and B and assign it to C. Okay, if an error comes up, it will capture that through the except block. Okay, here now as value error, raise it as value error. Okay, and then print, you understand, print here we can put this together just a bit lengthy, but it's okay. Print F, array mismatch, this is equal to shape of that. Then if no error exception is raised, return the matrix multiplication of A and B. So run this, I have the function in my namespace. Here, what I'll do is, unlike previous times, I had coded the arrays, but here I randomly generate an array of size or shape 2 by 3 as A, and then an array B of shape 1 by 4. I'm not interested in the content because they are random values, but I'm just particular about the shapes and what the output shape will look like when we multiply them using matrix multiplication. So if we run this, what do we have? It throws up, you see, the user can see that you have a shape mismatch. But if, for example, I turn this to 3 and I run this, there is no exception thrown up, and then it returns an array of shape 2 by 4. Likewise, if I return this as 1 and run again, what do we have? It throws up. But down inside, you can see the value error gives you detail of what is happening inside the code, and it still goes further to tell you there's a mismatch of shape. But the user can easily see the matrix multiplication error and then quickly fix that. Let's write a version 2 of this, and I'll call that mathmol underscore v2 A and B. Here, instead of using the try and except, I can raise the error directly. So I will say if the shape of A, okay, I use -1 there, so numpy figures out the last shape. So in other words, if the number of columns of A is not equal to the number of rows of B, raise the value error, and that value error is that, I can pull this together, is that mismatch dimension of arrays, shape of this must be equal to that. Okay, and then if no error is raised, return the scalar multiplication or the dot multiplication of A and B. So if I run this again, I have my version 2. Here I randomly generate an array, okay, a three-dimensional array for A of 2 by 3 by 5, and for B, a 4 by 1. I want to see the output shape. I'm not really interested in the random values generated in the array or the, the values in the array. So if you run this, what happens? You see here, you still have a value error thrown up because I raised the value error, and then it prints to me what the value error is. So I can easily go here and correct this. If I have this shape and I run, the value error is gone. I can see the output is 2 by 3 by 4 because 5 is equal to 5 and it returns 2, 3, 4. So I return this again as 2. If I run it, it throws up the same value error. So, as a summary of what we have just done and our take home, error handling is an important part of writing robust and reliable Python code. By using the try and except statement, you can handle errors in a controlled manner and prevent your program from crashing. Okay, it allows you to be specific when catching exceptions instead of using the general exceptions. Okay, here you try to catch the specific exceptions that you expect to occur. So while you're writing your code, you expect certain exceptions to occur if a user, puts in or imputes a wrong argument. So you capture specifically those exceptions. Also, it gives you that opportunity to provide informative message to users, as it will help users to understand what went wrong and how to fix it. Okay, with this, we have come to the end of this video. I intended it to be very, very short and descriptive. So if you find anything ambiguous here, please leave it in the comment section. If there's anything you want me to address, okay, based on this video, also leave it in the comment section. Please like my video, share this video, subscribe to my YouTube channel if you have not done so. Okay, click the notification bell so that you get notified whenever I upload new videos. I will see you in my next video. Bye.